Hi Expo, this is the notes for 11.4c, adding and subtracting rational expressions, day 3. One more type of denominator left that we haven't looked at, and that would be binomials, how that changes the LCD process, and how we can get these simplified as much as possible. Before we do that, one review problem. We have x over 6x minus parentheses x plus 1 over 2x squared. First thing I would do is write down the lowest common denominator. The lowest common multiple of 6 and 2 is 6, and x squared, we always take that highest exponent right away for the LCD. So all this one is missing is an x over x. This one needs to be multiplied by 3 over 3, so that both of the denominators are 6x squared. So up top, we have an x squared over 6x squared. And then we have a minus sign, and then we have parentheses, 3x plus 3, once we distribute the 3 in, over 6x squared. Now our denominators are the same. One thing that's good to do with subtracting an entire group or subtracting a binomial is to add the opposite. Okay, we're going to change this to a plus sign. We're going to flip the signs of everything inside. So a negative 3x and negative 3, okay? Adding the opposites. So we have an x squared that doesn't combine with anything else in the right-hand fraction, and then in the right-hand fraction we don't have any common like terms either, so negative 3x and negative 3 is the best that we can do. On the bottom we have 6x squared. We look and see if we can factor. There's not going to be any numbers that multiply to negative 3 that add to negative 3. 1 times negative 3 would be negative 2, and negative 1 times 3 would be positive 2. So up top, this cannot be factored. There's no greatest common factor, and I can't use my trinomial factoring. So this is my final answer for number 1. Okay, moving on. All right, so now you see on the bottom we have a 6x minus 1 and a 6x plus 1. So these really are not the same denominator because of these signs. The signs are different. So how do we make sure that we get the lowest common denominator before we can add the 1 and the 3 up top? Well, what happens is we need to essentially just multiply the two denominators together. So when we're trying to find the lowest common denominator between two binomials, or maybe it's one monomial, one binomial, which I think we'll see in a couple examples here, all we got to do is put them next to each other. We smush them together. So we look at what each one is missing. The one on the left has the 6x minus 1, so it needs the 6x plus 1. Whatever you do to the top, you have to do to the bottom. This one has the 6x plus 1, so it needs the 6x minus 1. And again, whatever you do to the top, you do to the bottom. So the process of finding the lowest common denominator is just multiply the left fraction by the denominator on the right, and multiply the right fraction by the denominator on the left. Just multiply by the denominator that it doesn't have. All right, so then let's simplify this as much as we can. We're going to distribute this 1 in, again, distributing that 1 into the 6x plus 1. We stay at 6x plus 1. So this is the left-hand fraction. On the top, that's what we have. On the bottom, we have 6x plus 1, 6x minus 1. You'll be tempted to cancel that. We have two 6x plus 1s. But don't. We want to have these be the same denominator, so we had to multiply by something, which we would be able to reduce it, but we don't want to do that in this situation. 3 can get multiplied into both of these. We can get 18x, 3 times 6x, and 3 times negative 1, which is negative 3. And this is over 6x plus 1, 6x minus 1. Okay, now the denominators are the same, which allows us to combine like terms. So I'm going to go down here for my next step. I can do the 6x and the 18x. They're both positive. They both are x to the 1. That gives me 24x. And then I have a 1 and a negative 3 that can combine. the constants, that's going to give us negative 2. All of this is over 6x plus 1, 6x minus 1, and then one step to take out a GCF of the top and see if we can reduce anything. So both the numbers in the top are even, so I'm going to take a 2 out, and I end up with 12x minus 1, which isn't quite what I wanted. I'm not going to be able to cancel anything, but this is going to be our very most simplified version of this problem. Okay. We always look to factor just in case there's some reducing. We don't want to FOIL anything or redistribute anything at the end. Just leave everything in factored form. If there is anything to reduce, then we can certainly do so. But a lot of times there won't be anything to reduce. All right, moving on. We have x plus 4 as one of our denominators and x minus 4 as the other. What we're going to do is we're going to just smush those together. X plus 4, x minus 4, that is our lowest common denominator. So with these, don't overthink it. Just multiply each fraction by whichever denominator it doesn't already have. So this one's getting multiplied by x minus 4s. This one's getting multiplied by x plus 4s. We need those denominators to be the same. Okay, perfect. Let's distribute that stuff. X has to go into both x and negative 4. We get x squared minus 4x. This is over x plus 4, x minus 4. We have a minus problem this time. We're going to do 3 times x and 3 times 4. So we have 3x and 12. And then be careful here. We're subtracting an entire group of stuff. So if you want to look at this as distributing the negative and flipping the signs, that's a good idea. We're really adding a negative 3x and a negative 12. Okay? When you're subtracting those fractions, think about adding the opposite. Change it to addition and then flip the signs inside the second parentheses. Okay? I only have one x squared term here, so x squared is going to stay the same. I have a negative 4x and a negative 3x that will combine to negative 7x, and then I have a negative 12. Those are my, that's the result of combining all the like terms in the numerators. On the bottom I have x plus 4 and I have x minus 4. Now this looks like something that we should check for factoring. Okay, are there two numbers that multiply to negative 12 that add to negative 7? And there won't be. Okay, 3 and 4 are only 1 apart. 2 and 6 are 4 apart. 12 and 1 are 11 apart. None of the factors of 12 are 7 apart. So again, I'm not able to cancel, and that's a pretty common result with these. Sometimes you can do a GCF and reduce a little bit, but for this one, there's no further steps to take since we don't want to do any distribution on the bottom. All right, one more example, and then we should be feeling pretty confident, I think. Let's try this one, and I'm going to have you just pause the video, give it a shot, and then when you're ready, hit play, and we'll go through the answer. Go ahead and hit pause. All right, so hopefully you've given this a shot. The lowest common denominator is x minus 5 times x plus 3. Smush those denominators together. So this one was getting multiplied by x plus 3's. And up here we have something a little bit tougher, and we'll talk about that in a second. Over here we have x minus 5 over x minus 5. Again, you're multiplying each fraction by the denominator that they don't have, the other fraction's denominator. Okay. Up here, let me just point this out to you. This right here is going to be FOIL. Okay, don't forget that sometimes you need to FOIL these. First, outside, inside, and last. So I'm going to go over here to continue showing my work. So we have, when we FOIL that, we have x squared plus 1x plus 3x plus 3. Okay, when you FOIL that thing that I've highlighted up in the left, Okay, but then these are just going to combine to be 4x, 1x and 3x. So I'm just going to rewrite that. Okay, we have x squared plus 4x plus 3. On the bottom, we have x minus 5 times x minus 3. We're adding this time. We're distributing x squareds in. So we have x is in, x squared minus 5x over x plus, or x minus 5, and then x plus 3. Okay, same denominators. All right, now that our denominators are the same, we can combine like terms. So we have an x squared and another x squared. That's going to make 2x squared. We have a 4x and a negative 5x. That's going to add to negative 1x. We have one constant of a positive 3. All of this is over x minus 5 times x minus 3. You don't need to FOIL the bottom. We can look to see if there's a way to factor the 2x squared minus x plus 3 up top, but we're, again, not going to find a way. Since this is positive here, we're not going to be able to factor this. We would have to either use 2 positive numbers or 2 negative numbers, but I'm not going to get 2 negative numbers that multiply to 3 that add a negative 1. So this is our answer. So again, that's kind of the nice thing about using a lowest common denominator or a least common denominator is a lot of times you don't have much reducing at the end. So a lot of these you won't have a lot of factoring or reducing that you can do, canceling that you can do, but you always check for it. Sometimes once in a while you can get something on the GCF. All right, thanks for watching. That was the 11.4C notes. Have a great day.